Hey everybody, welcome to our daily live stream. I'm Patrick Spano with my buddy Alex Torres, and today we'll be covering miscellaneous ACT math concepts that are imperative to know and very good to know for the ACT math portion. So I'll let you start it off, Alex, if you want.
Alrighty, how you doing today, Patrick?
Very well, thank you. Excited to watch you work your magic here as we pivot to ACT math.
Yes, let's hope it lives up to that. So I was working with a student yesterday, a wonderful student, great person, but someone who definitely needs to be nudged a little bit as far as, doing the work that needs to be done before setting foot in one of these tests. When you're coming into a prep test like an SAT or an ACT, you have two levels of what you need to know. You have general ability, which we just can't control. Some of us are better at verbal, better at math, better at this, better at that. And then you've got content, which you've been exposed to. If you have a good tutor, if you have the right person showing you the right stuff, you've been around the stuff. So now imagine, what's your excuse? You've seen it, you know this rule. This rule shows up on the ACT and you still don't get it. So as much as we love our students and we want to be nice and sweet and kind to them, we also have to be a little realistic and say, hey, this is on you. You got to know this stuff. And there's a lot of it on the ACT, a lot of stuff that, if you know that rule, then you'll know how to handle it on a test. And if you don't know the rule, you won't know how to handle it. And it's just simply that black and white. So we're talking about the things that are in your control when you're approaching one of these tests. And there's plenty of that. So we're going to go for about 25 minutes today. And we will not talk about all of them. This will be a work in progress. Notice that my page here is titled memorization. And that's because these are just things that you just simply need to commit to memory. Knowing them doesn't make you more smart. Not knowing them doesn't make you less smart. But these are questions that might come up on an ACT. So if you want to be ready for them, you've got to go ahead and do the work memorizing. So one of the first ones is, one that I feel like I see this on every single ACT. Sine squared of something of some angle plus cosine squared of some angle equals 1. So you'll see tons of questions that are just kind of telling you something that involves sine squared. So as an example, if sine squared equals 4/9, the question will say, find cosine squared. So sine squared of x equals 4/9. I already messed it up. Cosine squared of x would be what? So all we're doing for a question like this is just simply saying, what other number would we need in order for this to amount to 1? And the answer in this case would be 5/9, because 4/9 plus some number, let's call it b, has to equal 1. And now just algebraically, I might take away 4/9 from both sides. And this 1 is really the same as 9/9. So 9/9 minus 4/9 is 5/9. And so that's the idea right there that says, if you see anything to the effect of sine squared and cosine squared together, it might just be referencing what you need to remember, which is that these things have to add up to 1. So nice, easy rule, right, Patrick?
Yes, and I also just wanted to maybe mention that sometimes on the ACT math sections, they give you certain trigonometric proofs. But again, as a rule of thumb, I think it's better to just know them by heart. But I also just wanted to mention that oftentimes on the trig questions, they do give you the proofs. What are your thoughts on that? Better just have them memerized in case they don't
like
give
as
them.
far like you mean like the formulas?
Correct. They'll give you sometimes a formula such as that one, or there's another one I don't remember exactly off the top of my head, but it tends to appear sometimes.
Yeah, no, there are tons of formulas. The ACT kind of quietly will judge for you whether this is a formula you should know. Like you should know this. They do a little bit of that. And then there are ones that are just a little more on the side of complexity that they'll kind of judge for you. No, this is a more challenging one. And the ultimate one of those, and maybe we'll go into this next, is the law of sines and cosines. In about 95% of the situations that I've seen on the ACT, the law of sines and cosines are given to you, but there are situations where they're just not given to you. So we're noticing a lack of consistency in the test writers. You know, sometimes they're making you responsible and sometimes they're not. And who knows if there's some kind of advanced science that goes into that. But, you know, if you're a top student, you intend to try to get something on the ACT math in the range of 31 or above, then it's your responsibility to know these rules. So the law of sines would be sine A over A equals sine B over B. And we'll explain how that works in a second. The law of cosines would be c squared equals a squared plus b squared minus 2ab cos c. I can imagine that just looks kind of complicated at the outset, but you know, all these things, once you know them, it's not a big deal. So you got the law of sines, the law of cosines, and maybe as important as the rule is knowing when to use each rule. And a lot of tutors would fall short of telling you this, to be honest. The law of sines is what you use when you have two sides of a triangle and two angles in the triangle. And in that situation, one of these things is the unknown. And like I said, I'm going to illustrate this in a second. The law of cosines is what you use when you have three sides and one angle, and one of these things is an unknown. So we'll go ahead and illustrate these out. So for the law of sines, let's just say I've got, you know, a 42-degree angle, 56-degree angle, and x. So when we talk about sine and cosine, we're talking about sine and cosine of an angle, right? So so then you take the two angles. But the big thing to emphasize here is that these two rules are all about the relationship between the angle and the side across from that angle. So this angle right here and the side across from this angle, like that. So there's a relationship here between the 42 and the 7, the 56 and the x. And Patrick, if you have your graphing calculator handy, you could maybe be my calculator buddy here. But this would basically be sine of 42 over 7 equals sine of 56 over x. And then, by the way, whenever you're in a situation where you have a proportion, you're always encouraged to cross multiply. That's a rule that is infrequently ever, not true. It's one of these rules that, is really very powerful. So we would say x sine 42 equals 7 sine 56. And then we'd be dividing by sine 42. So x is basically 7 sine 56 over sine 42. And beware of questions where you might just blindly throw this into your calculator and then look at the answer choices, and the right answer actually looks like 7 sine 56 over sine 42. So on a test with so much time pressure, one of the gimmicks is to kind of give you that answer. And basically, they've duped you into calculating when you didn't have to calculate, and therefore wasting your time. So Patrick, what does that come out to?
3.98338372. I think we can leave it at the hundredths place. 3.98. Yeah.
7 sine 56 over sine 42.
I believe.
Are you in degrees or radians, brother?
Therein might be the issue.
And that's our recommendation for the day. So we actually staged this situation for you guys to show you how important it would be.
He doctored my calculator while I wasn't home.
Your cat stepped on the buttons.
You tinkered with it.
That was awesome. So then, okay, getting into law of cosines now. So the law of cosines. Now, okay, by the way, how did I know that, by the way? There's a little rule about triangles that does come up on the ACT that says if you have a small, medium, and large angle in a triangle, then this has to be the largest side, this has to be the medium, and this has to be the small. So in our situation, I knew that the 56 had to be across from a longer side. The x had to be bigger than 7 because 42 is smaller, and so the side across from 42 has to be smaller than that. So we're talking about relationships within triangles right there. And jumping into the law of cosines now, an example of that would be a situation where you've got, let's say, 63-degree angle here. And I'll call this 7, 9. Actually, you know what? I'm going to make this A and make this a number. So 7, 8, and the letter A. Okay, so now we've got 3 sides and 1 angle. The big thing about the law of cosines is it's the relationship, once again, just like law of sines, the relationship between the angle and the side across from that angle. And what you need to know is that these 2 other sides are kind of interchangeable. So for instance, in the Pythagorean theorem, when I say a squared plus b squared equals c squared, it really doesn't matter which one's a and which one's b, because they're just a squared and b squared. They're on one side, and it's the commutative property, right? Where it doesn't matter what order they're in. But here, here it's the 8 and the 7 that are kind of the interchangeable. They're the a and b in the formula right there. So we'll set up a squared equals 7 squared plus 8 squared minus 2 times 7 times 8 cosine of the angle. So we're doing 7 squared plus 8 squared minus 2 times 7 times 8 cosine 63. And then we're going to take the square root of that. So let's see.
I'll let you take this calculation. I'm having issues with my calculator.
Live TV, ladies and gentlemen. That's what happens. Times 8 cos 63. Okay, so what we have for a squared here is 62.1 generally. And now we can take the square root of that. If you're on a TI-84, that would be raising it to the 1/2 power, the fast way to do it, 7.9. So here you get 7.9 as the missing side. And I kind of stopped for a moment as I was figuring out how to set up this problem, because I was thinking of making the variable one of the green ones. And that would be maybe level 2 of this question, where you have a number on the left side of the equal sign and one of a and b is the variable. It wouldn't make a difference. You set it up the same way, but it would probably solve in that situation using like the quadratic formula or factoring or something like that, which makes me glad that I did not use that as an example. So, alrighty. So moving right along now. Another important thing is you might get a quadratic situation and be asked how many solutions. So how many solutions? And if you have a quadratic and you're asked how many solutions or anything to that effect, or you might be told the number of solutions and expected to know what to do with that, that's code for the discriminant. So some people have really, their math class really went into a lot of detail on the discriminant and they're experts on this, and this next segment might be boring. But from my experience, most students out there do need some help with this. So the discriminant comes from the idea of the quadratic formula. So x is negative b plus or minus, and this is equally prevalent on the SAT as it is on the ACT. So that's the quadratic formula right there. If you have a quadratic that doesn't factor, then you're going to use this. But putting fake numbers, just making up some numbers to go in here, look what happens as the discriminant varies. So I might get 2 plus or minus root 4 over 3, 2 plus or minus root 0 over 3, and 2 plus or minus root negative 4 over 3. So what is it that we're doing? We're taking the quadratic formula and we're varying the thing under the radical. So the discriminant is the thing under the radical. It's the b squared minus 4ac. And as we're solving each of these, as we're adding 2 and taking away 2, because the square root of 4 is 2 here, we're going to be doing 2 different operations. So 2 plus 2 over 3, 2 minus 2 over 3. I would have 2 answers here, 2 solutions. And that is when the discriminant is positive, you have 2 solutions. When the discriminant is 0, here, we're just adding and taking away 0. We're not doing anything. So the answer would just be 2 over 3. There would just be 1 answer here. And on the last one, if the discriminant is negative, well, that's breaking one of our rules in math. You can't have a negative under a radical, so we're not allowed to proceed here. This is the proverbial no solution, 0 answers. So if I'm being asked how many solutions in a situation like this, I just want to know that, the a is the coefficient of the x squared, the b is the coefficient of the x, the c is the coefficient, the constant that hangs off the end. So a, b, and c in that order. And then you'll just arrange b squared minus 4ac. So 7 squared minus 4 times 1 times 50. So here we get 49 minus 200. So we have a negative discriminant. And how many answers would that be? It would be 0 solutions with a negative discriminant, which is our definition that we just laid out right here. So depending on the sign of the discriminant, we know the number of answers. So level 2 of a question like this would tell you, okay, I have y equals, let's hope I don't mess this one up, because sometimes when you make questions up off the top of your head, you create like no solution situations. But 4x squared plus bx plus 9 has one solution, and the question will say find b. So this situation has one solution, find b. So what are we supposed to kind of know here? Just notice the difference between, like, I don't know, if your parents were just the most educational, motivated parents in the world and started training you on old SAT stuff pre-2016, then you'd notice the difference between the questions. The old SAT asked you to make associations, to think outside of the box, to be adaptive, all the creative things that would sort of train the CEOs of America in the future, or the world, right? But the ACT style of math is not that. It's not thinking outside of the box or fighting your way out of a situation. It's not an IQ test. This is a content-based test. So if I see a quadratic and I'm offered the number of solutions, do I know what that's referencing? And if I do, it means I've had training. So no question, these tests are very culturally biased, very class biased, but you know, stick with us and that won't affect you so much.
Correct. Gradeful's here to flip the paradigm on its head. So stay tuned, watch our videos, and as you said, there doesn't have to be any kind of cultural bias, which is again why we're out here providing all this free content. So bias no more.
And if you're ready to take that next step to get ready for your next SAT or ACT, we tutor students online all around the world, one-on-one, and we would love to start with you. Tell all your friends, and let's keep going with this. So this has one solution. That's a reference to the idea that the discriminant b squared minus 4ac is 0, because one solution was the situation above where the discriminant equaled 0. So we'll just go ahead and put the a, b, and c of this question. Now, by the way, the b variable ended up being the b, because you have the a, b, and c of a quadratic. But they'll often on these tests kind of make BC or make CA or something like that. That is inherently confusing if you're thinking in terms of A, B, and C. So keep a lookout for that. But b squared minus 4 times 9 equals 0. B squared minus 16 times 9, which I believe is 144. Am I right on that? Equals 0.
Get my calculator.
The calculator that you hurled across the room a second ago.
144.
So add 144 to both sides of the equation. Square root b equals plus or minus root 12. Don't forget the plus and minus. The one time you don't think about that is the time it could burn you. So that's the idea of implementing the discriminant. Okay, so just, kind of random. We're priding ourselves on compiling an exhaustive list of every memorization-based rule you would need in order to do well on ACT math. But you got to start somewhere. So we're just giving them to you. And I doubt there are any viewers out there who know every single rule we're mentioning, in particular this rule right here. How do either of these equations that I'm about to give you here, how do either of these factor? Definitely, if you're watching us in real time, definitely challenge you on this question. It's a challenge question. X to the 4th plus 7x squared plus 10. And another one would be x minus root x minus 12. So that's your Jeopardy question for the day. If you're watching us in real time or after the fact, how do these factor? And the reason why we're talking about this, we're going to refer to these as double or half-step quadratics. So these are similar. They're not really quadratics. This is just our sort of taxonomy for being able to call it something, because a quadratic has x squared and x and a number generally. So when you have x to the 4th or radical x, they're actually not quadratic. So, if there's anyone out there who's going to be a stickler about that, we already are aware of that. But
it's like a quadratic squared.
Yeah, it's related to a quadratic. It has the same format with a twist, right? So the idea is that if we had x squared plus 7x plus 10, that would factor a little more easily. Or if we had x squared minus x minus 12, that would factor a little more easily. This one would be, x plus 5, x plus 2. In terms of BC factoring here, we're looking for two numbers that add to 7 and multiply to 10. That's a little more of a basic lesson, but if you need help with that too, look through our library and you'll find lessons on this kind of thing. And then this other one, you're looking for two numbers that add to -1 and multiply to -12. So that would be x minus 4 and x plus 3. So if these factor to this, right, then the parallel situation that we had, so x to the 4th plus 7x squared plus 10 is going to factor to x squared plus 5 and x squared plus 2. So the way you work these out is by kind of finding the parallel situation from what we do know, which are the quadratics. And similarly here, x minus root x is the same thing, but it's sort of brought to the half power, the radical, minus 12 equals root x minus 4 and root x plus 3. So once again, if you know this, sorry to say, that does not make you smarter. If you don't know it, it doesn't make you less smart, but we're just trying to get you to cash in. And if you encounter any of these situations on a real ACT, then you'll be more ready for it. So Patrick, what % of students out there around the world do you think already knew this?
What percent of all the ACT
students?
test takers? I would say, if there was a way to figure it out, maybe 2.5%.
Okay, so that classifies this as a
the margin of error of 50%. But
okay, wow, you're really covering your bases. So this is random. This lesson is highly random, and we're sort of loving that fact. It's kind of the fun of it all. It's kind of randomly go around stuff you might need to know.
Should we add one more here? Should we add one more here, and then we can wrap it up after that? Thoughts?
Holy cow, where does the time go? So yeah, we could be doing these for months.
Doing math.
Yes, it sure does. And we could splice each of these concepts into a little mini video and just sort of embellish our library that way.
If there's any viewers that want that, make sure you comment any ACT math topics you'd like us to go in depth on. We're just trying to figure out exactly what content to pump out, but maybe we'll go for one more here, but then any idea or concept we can make a full-length video on also. Just comment.
All right, sounds good. So converting, let's say 27 square feet into square yards. So convert 27 feet squared, square feet, into square yards. So if I had the 27 square feet, well, the conversion between feet and yards, I was actually working with a Canadian student yesterday who didn't know that conversion really well. So, another way in which these tests are biased, right? Because they're just things that if you're from one country, you might know. But there are 3 feet in 1 yard. So there's 3 feet in 1 yard. So one of the wrong answer choices on this question is going to be 9, 27 divided by 3.
You know how many centimeters are in a meter, Alex?
100 cents in a dollar.
I was trying to stop you, right?
Yeah, man. Well, bring it. Let's go. So anyway, okay. But now if we have square feet, what is square? What does it mean to square something? It means you're multiplying it by itself. So to match the square feet, I don't just need feet. I need feet times feet. So I've got to double up this conversion. 1 yard over 3 more feet. And so now the two green things are equivalent. So, feet squared on the top, feet squared on the bottom. And now we've gone ahead and converted. So this cancels with these two. And so that leaves us with 27 over 9. And now we do have yard times yard, which is yard squared, square yard. Students around, let's say around the Oh, it was me who lost the connection. Do you hear me now? Okay, not sure if I have audio or not, but we lost a little connection there for a second. But I would say very few students around the world, I think you muted Patrick, very few students around the world would have known the answer to this question, in my opinion. So like we said, if you have any feedback for us, anything you'd like to see, any questions, comments, concerns, critiques, let us know. Otherwise, we'll see you tomorrow at the same time, noon Eastern time, every weekday. Thanks so much.